This is 11-1, solid geometry. We're going to be talking about 3D figures for the most part. So let's start with the warm-up. Hit play when you're ready to see the answers. So we have equilateral, triangle, regular hexagon, and parallelogram. So there's some important vocabulary here. Three-dimensional figures are called solids, and they can be made of curved surfaces or flat surfaces, or a combination of both. The flat surfaces are called the faces. So like the top area is what I would call this. That's the top face. And the edge is where the two surfaces intersect. The point where three or more faces intersect is called the vertex. So the edge is right here, and the vertex is like the corner, the very corner. The edge is where two sides meet basically, and the vertex is like a corner. The main thing that you need to know is that a prism is made of two figures formed by two parallel congruent polygonal faces. So basically any shape is what I'm saying with the figure that's not a circle, and those are called the bases, and they're connected by faces. So let's see, if we have like a triangle and another triangle and we connect those at the vertices, that's going to be your prism. A cylinder is the same idea, but it's like a circle and a circle, and then they're connected like this. Oops, I missed. That's a cylinder. A pyramid comes to a point. So it has one base. Could be different shape. Could be shaped like this. But either way, it's going to come up to meet at a point. So this one would, all of these would meet up here at this point. And a cone is basically a circular pyramid, is what I would think of it. Just like the cylinder is like a circular prism. So prisms don't come to a point. Pyramids come to a point. Super important. A cube is a prism that contains 6 faces, and here are some different prisms and pyramids. They're named by the shape of their base. So we have a triangular prism. It's two triangles connected. Rectangular prism, pentagonal prism, hexagonal prism. None of those come to a point. But look at all these. They all come to a point. So a triangle as the base comes up to a point. Rectangular base comes up to a point. Pentagon base comes up to a point, and hexagon base comes up to a point. Those are all pyramids. Okay, these are just time consuming, so I'll do one of them for you. So let's jump down to the top is a prism because it doesn't come to a point. The bottom one is going to be a pyramid, but we have to be specific. So if we count the base, it has 1, 2, 3, 4, 5 sides, so it's a pentagonal base. Pentagonal, pentagonal. And it's a pyramid since it comes to a point. And the vertices it has F, B, A, E, D, C. The edges, we have all of them that come up to the point. So we have BF, AF, CF, DF, and EF, and then we have all that meet together on the bottom. So like BA, for instance, all those consecutive vertices. So BA, AE, ED, DC, CB. Okay, and the bases, there's only one base, and we can just name it by the letters. So we'll call it pentagon A, B, C, D, E. For the now you try, I'm going to do the second one for you on this one. If you want to do it on your own first, hit pause, and then wait. When you're ready, hit play. So this does not come to a point, so this is not a come up to one point, I should say. So this is not a pyramid, so I know it's a prism, and the bases are triangular. So it's a triangular prism. Has a lot of vertices. We have the T, U, V from the first base, and the W, X, Y from the second. And for the edges, we have TU, TV, and UV that make up the first triangle, and WX, XY, and YW that make up the second triangle. And then we have all of our edges that are connecting the two. So that would be a TW, UX, and VY. So there were 9 on this one. And then for our bases, we can name them as triangle TUV and triangle WXY. If you open up a 3D figure, like picture a cereal box, if you open up that cereal box, what would be, when it's all the way open, we would call that a net. So to identify from a shape from a net, think about folding it up and what it would look like. So if you take these sides and you fold them upwards, fold that up, and this one would come up, and that one would kind of connect over, fold over, and close up the shape. And these are all squares. It's definitely not coming to a point, so I know it's a prism. And since all of the bases are made of squares, I know that it's going to be a square prism. Here the base is a circle, and when you fold up this other part, I know it's going to come to a point. So a circle that comes to a point, well, we would call that, looks like an ice cream cone, right? We call that a cone. And this is a triangular base, so it's a triangular something, and when I fold up those triangles, is it going to come to a point or not? And it will come to a point, and so that's called a triangular pyramid. And here we have 2 circles as the bases, and if you kind of roll up the other part, that's going to be your cylinder. Okay, imagine slicing through a 3D figure. We call this a cross section when we slice through it, a piece of it. Some of you might have seen this on the map test. So to describe each cross section, we're talking about what shape would it make when we cross through, or when we slice through, I should say. When we slice through the 3D shape, what will we see? At the tip of a cone, you would see a point. If you slice through the middle of a pentagonal pyramid, you would see a pentagon. And if you slice this way through a 1, 2, 3, 4, 5, 6 hexagonal prism, you would get a hexagon. Slice through a cone, if you notice the red outline for you, that's going to be a triangle. I don't know why I drew that instead of writing triangle. And let's look at these. So it's asking us, if we slice through, how can we end up with an equilateral triangle, or which way would we slice through is kind of what it means. So if I want to find out for the equilateral triangle, I see that the equilateral triangle is like the top piece, so I know that I kind of have to cut through like this, going this way through it horizontally. That's what I'm trying to say. So if I cut through that horizontally, that's what it will result. Now to get a rectangle, I'd have to cut through this way. That's going to be vertically, like top to bottom. For the Now You Try, how can I chef cut a cube-shaped watermelon to make slices with triangular faces? So in order to do that, you're going to have to cut through this way. So it's vertically, but at an angle.